everyone. My name is Gavis Nabo. I'm from Faculty of Informatics of Burapha University. Actually, I'm a Cambodian student who got a scholarship from the Highness Princess Royal to study at Burapha University. My presentation today is about empirical modeling for dynamic visualization of ICU patient data stream. Just keep a look at my outlines and of my talk today. And the introductions. Typically, the biomedical data stream are hard to visualize and dynamically to interact with them because of their varieties of the dimension and properties. And the challenging is that how to create interactive visualization for medical practitioner and student to explore the behavior of the biomedical data stream. And moreover, currently the most current visualization application are using conventional paradigm that prohibits user model interaction. So we want to use empirical modeling is conventional ways to build the dynamic visualization that are highly interactive. Okay, this is our related work about the data visualization domain, and this one, the list of the empirical modeling domain. And so you can look at my detail, the detail in my full paper because the time constraint. Okay, our research, we have the motivation to build novel interactive models for visualize the data stream and to enhance the experiment of human-machine interaction for education purpose. And another one is to provide a learning space for medical education. And the last one, we want to introduce the empirical modeling, or we call it EM, as the alternative environment for researchers to explore their research in the new direction. Okay, this is our proposal. And let's start with the empirical modeling. What is empirical modeling? Empirical modeling is an unconventional paradigm in computer science, which is found by Mr. Bayon in 1985 in the Department of Computer Science, University of Warwick in the UK. And actually, EM provides a sense of real life under three key concepts. And the three key concepts are: one is observable. It's like a model's element that we observe. And another one is dependencies. Dependency is about indicate how the observable depend on each other. And the last one is agencies. It's about the trigger actions that happen on the observable. So right now I want to show you the diagram, how do they work. First example, we have observable A and B, but observable B is depend on observable A. Whenever the action happen on the observable A, then the B automatically update too. It's about the principles of EM. And right now, to more understanding about the principle of EM of three concepts, example for the vital sign symptom detection by EM principle. We have observable T as a time movement, and HR represents to the heart rate, and that's measurement at the T time. And HR symptom is heart rate detections that will detect when the heart rate value change. So when the agency time T is updated, directly heart rate also update and the symptom also update too. This is the generals of the principle of EM. And right now I want to show you the difference between unconventional and conventional paradigm. You can see at the You can see at the source code of 2, the unconventional paradigm, they use a very short code that reduce much of coding effort than the conventional one. So if you are imagining that we have thousands of line code, so in this unconventional paradigm can reduce many time and effort of the programmer. Oh, okay, next. And the above is the EM, and then we use the JS Eden. It's one of the environment of EM. JSEM is a web-based environment for empirical modeling that first prototyped by Tim Monk in 2010 in the Warwick University. And it is also a JavaScript based of the Eden interpreter, and it's open access for the user model interaction. And now let's see what is idea of dependency. Like example A is B1 times 10. You can imagine about the spreadsheet, the cell spreadsheet, the referencing of the cell spreadsheet. It is really working the same way to the dependency of the EM. And moreover, in JS Eden, we can embed this JavaScript into the JSON, like the figure that I saw in the slide. And this figure is so how we can replay the data stream by using the JS Eden, but using JS Eden with our Eden library that we can we just use the Eden clock, just the library of the Eden, and the procedure, the trigger procedure. So we just code just some few lines of code. But if we use the conventional one, we have to code many lines of code. So it's very efficient for programming. And this one is the JS Eden web-based, the startup before. When we open the model, we will see these 3 windows. Canvas. The Canvas 2D is about how to show the element outside. And the script input is going to let the user to insert or update the observable to the model. And the project list is just show the project that we have built in our environment. And the key concept, the 3 key concepts in JS Eden we can see in the environment. It's in the JS Eden environment, like dependency map. In here we can browse and assert the observable that depend on each other. Like we have this one observable that depend on many observables, and the observable is so after all the observable that we have defined in the model. We can search it, and we can update all the value in here. And the agency list is about the trigger procedure that we have define in our model. Actually, we got a data set from the VCO bank, which is open access and free of charge. It named the multiple parameter intelligent monitoring in the intensive care, and they have time series data set contain thousands of records as our model input, and each record contains different various vital sign observation, and they have various of time length record. And our design, our process design with this. Firstly, we got a data stream in the VCO bank, and then the data set will be loaded to the processing step. After processing step, we have two kinds of data set: is short-term data set and long-term data set. I will detail you about this one later. And after that, the model management is ready to give a task for the EMDV. This is our main process here. And when the user load the data, And then the model EMDVs visualize the data output. And then the user can interact back to the model. Okay. Now I would like to tell you about the pre-processing. We have 3 steps of pre-processing. First one, we download the data set from the Visual Bank by using unit command. Just use the wget, and we can get all the data set from the web of the Visual Bank. And then we convert the data set into model data structure as we saw in the figure, or you can see in my full paper. And by using the library of the Visual Toolkit from Visual Bank 2. It was called WFDB, and we use some unit command to change the value, the string of the file to our data structure. And last one, we just classify the data set into 3. But the first one we discard because it is invalid one. Because some record are just error record or only have 5 minutes list. So we take only the record about longer, 5 minutes until 30, and the long term as over 30 minutes. Okay, right now is our main point is the EMDV implementation. We organize the EMDV as in MVC, like you know, model, controller, and view. In the model section, we create a base observable file that contain the used to initialize all the observable value. And for the controller, we have dependency. It's about file to write the dependency between the observable all together, and we create a function file to define a call function that the model will call. And the last one is trigger procedure. It's about agency procedure. And the view, we have only 5 visualization view to display all the output outside. Okay, for the model, we can see the model overview here. We have 5 components. 1, 2, and 3 are the interactive component. The user can interact with this component, but number 4 and 5 are the view-only component. This one is about the vital sign and the current measurement of the physiological. This one is the line chart to show up in real time. And we can interact by playing forward, backward, and speed up. And we can change the line height and the column to show in the chart. Okay. For our result, we have evaluation with 5 platforms.